Hello. All right. Well, we are recording now. Thanks everybody for joining us. Another session of the Data and AI Architecture Virtual Group. Today with us is Reitse Eskens, who's going to talk to us all about coding, deploying, maintaining Azure Infra with confidence, all about using infrastructure as code methodology. It's just really, really cool. This is the way to do things nowadays when you're dealing with the cloud or even on-prem as well. If you're heavily virtualized, you can do a lot of it all the infrastructure deployment config through code. And this is a great topic when you're thinking about how you're going to architect and deploy a new system. Now, keep in mind, we have a few more sessions coming before we wrap up the year. In a couple of weeks, we'll have another session about Fabric. Then we'll have a really cool session coming up to close out the year, December 15, on using machine learning to tackle climate change. Then we're going to take a break for about a month, and we will come back in the middle of January with some more sessions to kick off 2024. If anybody's ever interested in speaking, feel free to send me a message as well on the meetup, and we will get you in the calendar as well. All right, so without further ado, I'm going to pass it on to Reitse. If you have some questions, put it on the chat. Reitse, I don't know if you want to handle them as we go. You want to save them till the end. It's up to you.
No, handle them as we go. So please interrupt when I'm speaking. If you've got a question or anything, I'm happy to answer them immediately.
Okay, sounds good. All right, the
Cool.
floor is yours, Reitse. I'm going to mute myself as well.
Thank you. Let me share my screen, which should be running about now. And thank you for letting me be your lunchtime entertainment. At least if I understood Warner well enough, it's about your lunchtime. So this is what I'm going to be talking about. Coding, deploying, maintaining your infrastructure with a little bit of confidence. Of course, slide title. One thing before I get started, both this slide deck and the code I'll be showing you are available through GitHub. So you can download the stuff and play with it as much as you like, change it, whatever. One word of warning, as with all the code you're downloading from the internet, please think about it, read it, evaluate it, and only then try and run it. Always review your deployment before adding any data to it, because code can be faulty or something can be happening that might create a leak. So be careful. And it's not production grade. It's stuff I built together. I know it's working, but it's not production level. It's just a starting point for you to get used to all the stuff. All right. As I said, if you've got any questions, jump in. You can either ask me to or unmute yourself and ask the question, or put it in the chat, and I think Warner will ask the question. I can already see one hand up from Paul. You have a question?
Yes. What is the GitHub repo?
I'll share the link to the GitHub repo in a few minutes. So if you have a few minutes of patience, I'll show you the link. All right. Cool. If we're going to talk about deploying resources on Azure, with anything, we need to think about security. And when you think about security, you also need to think about security incidents, stuff that's leaking. I've been doing a little bit of research, and this was one of the things that came up. 480 million breached records. That's a lot. 14.8% decrease in security incidents. All right, we're moving in the right direction, but we're still not really there because there are too many incidents, too many data leaks. My own country isn't doing much better, to be honest. We've got a lot of data leaks, cyber attacks, all the stuff. It's always happening, and it's easy to make a mistake. So when you're looking at your chief security officer or any security officer, that person is going to say this. Please stay out of these statistics because we don't want to be in them. We want our data to be secure. We want the resource to be secure. So that will be one major part of my session. Now this is me. There's a lot of stuff on it that's mostly cool. This is me. There's always the also the QR code for my GitHub repository. So if you follow the QR code, the link, you'll get to my GitHub repository and get all the good stuff. If you're joining late and you think, oh, I missed the code, no worries, I'll show it at the end again. Now let's start a story. Suppose you're working at a company and they've got a brilliant big idea. Let's move our entire data solution or whatever solution we've got to the cloud. Well, that can go wrong, right? Wrong. A lot of things can go wrong. So we need, as data people, as infrastructure people, as architects, we need to think about a lot of stuff. So we need to architect for our security. We need to learn and use infrastructure as code because we do not want to keep clicking. ClickUps is something of the past, so please don't click in the Azure portal, try and code your stuff. Only then can you really start building your solution. If you want to do a proof of concept, you can click. Be my guest. But for your final solution, for your DTAP environment, please use code because you want it to be repeatable. But before, you need to architect for security. So let's suppose we're going to deploy some stuff on Azure. We need to architect for security. So we need to think about more things than just resource security, more things than just user security. We need to understand what can happen. So we need to assume that we're breached. How are we going to handle that? All these things are things we need to think about. Resource security is sometimes quite easy because there are a few buttons or checkboxes you can click in the Azure resources or set in the code, and the resource is more or less secure. So let's say we're going to deploy some stuff and we've clicked all the stuff, all the settings. We're not allowing any public communication to our resources, but everything is within our own virtual network. Oh, but this is all the resource security we need. No, one of the things we need are so-called policies, and policies are set at the highest level within Azure, in my opinion, on the management group level. And I'll show you in a diagram later in this session how that works. And then we're going to create, for instance, a policy to prevent unwanted changes or deployments. One example of this. Earlier this year, Microsoft started quite heavily campaigning all users of Azure. Everyone had some kind of agreement with Microsoft on Azure to please make sure MFA was enabled. Now, why were they doing that? They found that breaches were not, or people logging into the Azure tenants that were not supposed to log in, were not really after data. What they were doing, they were deploying machines, big ones, the ones that will cost you $1,000 a minute, those kind of big machines, to start mining Bitcoins. And you can understand bills ran up quickly, big bills, $100,000 million bills were sent to customers who said, we didn't know what happened. It wasn't us. And Microsoft said, well, it was some kind of user of yours on your side, so you've got to pay. How can you prevent this? Quite easily by creating a policy. Make sure the policy is the highest level and make sure people cannot deploy VMs outside a certain range. So for instance, in my company, I've got a policy that says you can only deploy D-series VMs. Of course, coworkers come running up to me. I need an E-series, I need an F-series, I need whatever. Okay, what do you need? What do you need it for? And then I can make an exception for you. But standard, you cannot deploy a resource that's not in my list, preventing the deployment of those huge, expensive VMs. Now, something else you might want to do is to add a lock to your resource. Not to lock it down. The only thing a lock will do is to prevent it being accidentally changed or deleted, because you want your resource to be in place. and not change without somebody tampering with it. Now, if you're using infrastructure as code, and most important, or the language I've seen it with most is Terraform. It's a stateful language, so it checks what resource is there, what's the resource definition in my code, and if there's a change, I'm gonna change the resource to match the code. So if somebody started changing resources, it will be reverted in the code. So what you want to do is, if you need to change your resource, change it in code. Security is, or architecting for security is also more than user security. I hope the first one, MFA, 2FA, you're using it everywhere, and I don't have to explain about things like that. You might want to think about things like enable just-in-time access. Things like privileged identity management, where everybody's just a regular user and you can request to be elevated to a higher privilege level. You also need to educate your key users, the people who have more privileges than the standard user. They are the ones that are the biggest risk. Now, I'm quoting myself because it's not really a risk, but they're the ones that, well, if their account gets breached, their account has a bigger risk. But also, when you're deploying your resources, make sure wherever possible you're using Key Vault. Key Vault is not just use a password; it can contain connection strings, of course, passwords, all kinds of encryption keys. Make sure you use it wherever you can. I'll show you in the code demo later how we can do that. Something else. Assume you're breached. What are you going to do? What is your contingency plan? What can you shut down? If you've got 40 VPN connections, if you've got public IP addresses, how are you going to make sure that all your stuff is safe? And can you find out what the route was the hacker used to get in? Hackers are always constantly scanning for open ports, so make sure no ports are open or a minimal amount. If you're hosting a website, you're probably stuck with port 80 and 443. Cool, but make sure there's a reverse proxy between it to make sure that only the correct traffic gets in. Make sure SQL injection gets caught and handled. Always deny traffic, zero trust. Nothing gets through unless it's explicitly granted access. Now, there are a lot of guidelines out there, all the stuff that we need to be aware of. There are a lot of guidelines. So when you start architecting your security design, which is your first part, use them as guidelines and make sure your solution keeps working, because I found that if you've seen all the guidelines and you take them literally, you're stuck. Nothing works anymore because nothing is allowed to connect. So let's say we've created our security architecture. We know we don't want public endpoints. We don't want public IP addresses. Every resource has the allow public disabled. Now what? We need to connect, so we need to think about network connections. I'll get back to that later. Main thing is, remember to assume zero trust and assume breach. So now that we've thought of all the security, we're going to code the stuff, because we've already seen for ourselves. We tried a little bit in Azure. Clicking is fun, but every time we start clicking, we make different errors, or at least I make different errors, and every deployment is different. And I want a consistent deployment. I want a repeatable deployment. So what are we going to use? We're going to use infrastructure as code. Now it's a container term, if you will, where it's a way to describe our way of working. We're going to describe our infrastructure as code. It is the most easy way because we're going to type all the everything we want. you can run it over and over and over again. It's going to give the same result until we change stuff. And we can configure it with parameters. So it's not, you don't have to hard code everything. Luckily, we don't have to do that. Now the question is, what can we use? Because, well, when you look in Azure, you can export something called an ARM template. I've looked at those ARM templates and thought, yeah, cool, but I don't understand how to use them. So I thought, well, let's not use an ARM template, but what are my other options? First one I ran into were the AZ PowerShell commandlets. I like PowerShell a lot, so I gave it a go. And I quickly found that if you want to deploy something like a virtual machine, there are 20 odd flags you need to set about the sizing, the naming, the user, the password, all the stuff, the tier, the SKU, all the things you need to set to be able to deploy a VM. And if you work with PowerShell and you find out it's all single line, or you need some kind of escape character to be able to use multi-line, it's easy to make a mistake, especially if you're typing along and wrong button, enter, the commandlet start running, the deployment starts running, it's not what you want, and you become frustrated. Welcome to my world. So I quickly found PowerShell is cool, but it's not going to help me personally. So what do we want? Well, for me, I like a declarative language. I just like to put into code what I want as an end result and let the code handle everything for me. So Microsoft came up with a tool called Bicep. Bicep is an extension of ARM template. You know, ARM, Bicep. Well, I work in IT, so biceps are a bit of a mystery to me, but still. And they said, well, we're going to create Bicep, also a little bit of a reaction on the other languages, and you can deploy your resources with Bicep. Now, the Bicep language is, well, a bit different. I found it quite hard to get used to. There are funny things happening there. You need to get the right API endpoint with the right date configuration to get things running. And if something doesn't work, you need to switch to another API endpoint. For me, it was in the end too messy. I want clean code, not constantly changing endpoints, etc. So then we found, because I'm working for a company and we were exploring all the stuff with a number of colleagues, we found Terraform. And Terraform was completely declarative, but it was also stateful. So I'm going to type in what I want. I'm going to tell Terraform, build it. I'm going out, get some coffee. I'm coming back, and Terraform tells me I did it, or I ended up with an error. Cool. But the thing about Terraform is it's stateful. And what this means is that it saves the state of the deployment in a file. And whenever you rerun it, it's going to check the state of the state it's expecting against the code and against the real world. And all the changes will be fixed. So either resources will be removed or changed or added, whatever is needed. This is cool. This is what I want. I want my code to be leading and the Azure environment to follow my code. Well, that's my dream world. What happens in reality is that I'm deploying a database, for instance, and this database will be, let's say, a basic. It's cheap, $4 a month, something like that. And this database is running happily, and it does this work. You can't do much with it, but it is a database. And my data engineer coworker comes to me and says, well, I need a bigger database. And I need it now. Can I change it? Well, if my coworker would change it and would rerun the code, it would change the database back from the tiered SKU my coworker chose to the one that's in the code. The good thing is in Terraform, I can exclude things. So I can, and that's called a lifecycle. So I can tell it, well, check if there's a database. If it's there, cool. check a few parameters like public access, firewall thingies, whatever, but do not check the tree and SKU. It doesn't matter what it is. What this means, if the code runs again and my coworker has changed the tree and SKU from basic to standard level 2, Terraform will recognize it's changed from basic to standard level 2, but won't act on it. It'll just skip it. All right, cool, whatever, and move on. That's cool. So that way you can find a balance between making sure that all your code is leading your environment and giving some flexibility to the people using it. There are some other languages as well, like Terraform, which you can use over Terraform. Pulumi is another language. I haven't got much experience with them, so I can't judge them or tell much about them. I do know that some companies have almost wars on you should use Bicep or you should use Terraform or Terragrant or Pulumi or whatever. Not me. For me, the most important part is make a choice and make sure you get proficient with it. If you want to use Bicep, cool, it gets the job done. And if you're proficient with it, awesome. If you want to use Terraform, just as good. If you want to use Pulumi, be my guest. Whatever you use, make sure you get proficient at it. Now, the good thing is with code like this, you can load it into Azure DevOps and GitHub. Or GitHub or whatever you want to use, GitLab, any Git environment. So you can use your DevOps process, use CI/CD, version control, all the things you can do with your code. If you're going to click around in the Azure portal, good luck doing version control. The only option you'd have there was to export the ARM templates, which are usually incomplete, and saving them somewhere. That won't work for your process. You can adopt some Scrum ways as well, and you can even build pipelines to do a lot of the heavy lifting. So all you have to do is change your code, upload it to the repository, and automatically fire off a pipeline or manually do it, whatever has your preference. But it also allows for more people to look at your code. I mean, I know I'm brilliant. I never make any mistakes. I'm coding the best stuff there is out there. No, I'm not. But it's always a good idea to have somebody else look at your code, to have somebody else check out what's happening. If you're making mistakes, if things are accidentally wrongly configured, whatever. Making sure more people look at it, 4 eyes, 6 eyes, whatever. It improves the quality of your code, which means it improves the quality of your deployment, which means it improves the quality of your Azure environment. And that's what we're all after. You want to improve the quality. All right, so the demos I've created are created in Terraform, and I'm using PowerShell as a bit of a support act. As I said, it's not better or worse than Bicep, it's just different. In my demos, I've excluded the entire DevOps part because it adds a lot of complexity. And my focus in this talk and in my demo is really on the code part. All right. So we've learned the language, we've kind of designed our stuff. So it's time to start building our stuff, because talking theoretically, it's something we all can do. But now it's time to build our stuff. So we're going to build our stuff from the ground up. And to build our stuff from the ground up, we're starting high at the highest level. It sounds a bit contradictory, but this is the first part where we're going to work. We're going to create management groups. And management groups are kind of a high-level organization within Azure to keep workloads separated, to keep a lot of things organized. In this example here. Ooh, my highlight is a bit slow today. I've got my standard management group from the tenant, followed by a company management group. Within that, I've got a workload management group, a landing zone management group, and some custom management group. So I've already got some kind of separation between different management groups. And in each management group, I can apply a different policy or write a different policy and assign them in the resource groups that are inside my management group. Maybe one management group, for instance, development, can only use B series VMs. So I can create a policy there, only B series VMs. That's not a good idea for production. So for my production environment, my production management group, I want people to be able to use DEF machines, for instance. And I do not want them to use B-spec machines in production because I want performance there. Things like that you can build into your management groups. So let's get one level down. This is the hierarchy. We've got a management group. A management group has one or more subscriptions. A subscription has one or more resource groups, and a resource group has one or more resources. End-to-one relationship. Okay, cool. But what does this have to do with building? Well, the management group and the subscription are best built manually. So you're not building them, you're just requesting them. This is a part I usually click inside the Azure portal because it's not much work. It's only once and then we're done. They're there. The resource groups and resources, those are we're going to program. But this is the hierarchy. So you need to be aware of these layers. What I've found in, especially with new customers where we're doing greenfield projects, is that they think resources are directly connected to a subscription and resource groups are kind of management groups and all the terminology starts mixing up. So this one I've used a few times with customers and this is the relationship. Moving on. Now that we've decided how our architecture will be on a high level, we're going to zoom in. Now we're going back to the lowest level, which for me is networking. As I said, I want my environment as secure as possible, which means no public endpoints, only private endpoints. And to create a private endpoint, I need a network. So I need to create a virtual network with my subnet. And to create my virtual network, I need to think about my CIDR range. Why do I need to think about it? Well, later on, I might want to create a VPN connection to an on-premises environment. And the last thing you want is an overlap in CIDR ranges between Azure and your on-premises environment. I've been there. It gives different results when you want to connect to a resource, because it completely depends on which part of the network is quickest to respond. That's the one that gets the connection, and then things, well, don't happen because it's always the wrong one. You never end up where you need to be. You also need to think about your subnets, because you can define your CIDR range, which is the IP address, the four parts of the octet, and then /16, 17, 18, whatever you want to, up to 32, which is one IP address. But there are a few resources in Azure that have minimal amount for this extension. So they need minimal /27 for some reason. I know the VPN gateway needs quite a range, and Azure Bastion has some requirements as well. So you need to think about your subnets. Where do they fit? And if you want to stack your subnets, for instance, 10.0.0.0 to 10.0.0.5, the next one should start with 10.0.0.6. So you need to think about, all right, I've created this CIDR range in my subnet. What's the next one that I can use? So use a CIDR calculator to help you with that. Now that we've created our network, we need some security in our network as well. You could go big and deploy an Azure firewall, which will secure a lot of your network. But one thing people often forget is you can also secure every virtual network, but also every virtual network card, your network interface card, which is also connected to your private endpoint, with its own network security group, creating a layered network. So you might have your big firewall. Below that, you've got your network security group on your virtual network. And then you've got your network security group for your network interface card. All different layers where you can limit traffic that's allowed through. That's what you want. You want more layers to make sure only traffic that's really allowed through to that specific resource to pass through. Sounds a bit theoretical? This is how it looks. We're using private endpoints only, but what you can see here is that I've got my subnet with my private endpoint, and I've got an extra network security group protecting my network interface card. This one has only one target IP address. The source can be one or multiple other addresses. The other thing here is that I'm not allowing internet connections in. So if all the traffic that's going to my resource has to come from the internal network. I do not want internet to be able to connect with, at least not directly. Now, if you're creating a network security group rule, it's easy to just say, well, IP address A, IP address B, port number 3389, it's allowed, done. Next day you can remember, oh yeah, this were these IP addresses, I know what they're for. And 2 or 3 weeks later, you're going to look at it thinking, which machine is allowed to connect with RDP to this other machine? I have no clue. So you can add a description to your network security group rule. Please add them. It will help you when you're troubleshooting, when you're trying to find out why a connection doesn't work. It really helps. So I really do not want public access. All my internet connections should be refused. Now I can build my entire environment and tell people, yeah, I've done it. No connections are possible. But I think it's a British saying that that goes like, the proof is in the pudding. In other words, try it out. Try to connect to every resource from a public internet machine, whatever. See if you can make a connection. If you can, you found something to improve. If you can't, all right, now you've proven it's mildly secure. I'm always stressing our customers to get an external agency to test it for them. Because when I'm deploying something and I'm telling the customer I've done my work and I didn't fail, I'm kind of testing my own work, which doesn't really feel right. So I'm telling the customer, go find another party, another company, and let them test it out and see if I've done my work in a way that's acceptable, or maybe I need to improve something or change something. Work with those people. You can only improve. Now, if you want to connect to your environment in a secure way, either use a VPN or use Bastion if you need to connect to a virtual machine and you can't connect or build a VPN connection. Building VPN connections, it's hard. It will take you a few hours, but it's really worth the effort. When it's running, it's awesome stuff. Again, make sure you've got to connect side ranges. But Bastion is a really cool service. If you're using Bastion, you can just log into the Azure portal, go to the virtual machine. I want to connect to this virtual machine using Bastion. You can connect to it. You just get an interface in your browser. It's an awesome service. The basic one isn't really that expensive. If you get a standard one, you get a bit more remote desktop native like experience. Thing is, if you're using the standard version, you get remote desktop. You get the regular file you're used to. You can double click and you can transfer files easier. Thing is, you can transfer files easier. So it's easier to move data from your machine to the virtual machine in Azure, which may be a use case, but it's also easier to get them out. And there's no checking on what you're transferring. So you might even introduce a virus on that machine. So my personal belief is to always make sure you're using the basic one. It's limited, but by design and by the limitation, it's more secure. Finally, encrypt everything. By default, Microsoft has encrypted a lot of stuff. Make sure you encrypt your own stuff as well. Encrypt your data, add certificates, bring your own keys, stuff like that. Make sure you encrypt everything. Because with encryption, it's harder to get stuff out again. Both for you, but also for people who are, well, less intended to be good with your data. All right. I've been talking for almost half an hour now. Before I'm going to jump into the demos, Wona, are there any other questions?
Yeah, there was a question here about some resources for learning Terraform. So there's one there. And then another one is if you know some mechanism that could be used to do a health check on, for example, if you have an Azure SQL database for PostgreSQL that will have to be accessed from a jump host, like if there's a way to validate whether they're configured properly or not. Those are the two questions we got.
Okay. First one, for getting used to working with Terraform, what I found, there's no substitute for experience. Just try it out. The Terraform website has a lot of guidance on how to use specific pieces of code. I'll show you a few examples in my demo, but you just need to work with them. Try it out, find out what works for you, and learn by doing. Whatever you do, first of all, make sure you're not loading any data into your resource until you're convinced and really sure it's safe. Second, before you deploy a resource, check the pricing in the Azure pricing calculator. We've had an issue last year in the summer where we deployed log analytics, and we had a configuration mistake where we didn't have the per gigabyte setting, but reserved setting, which cost us about 700 euros per day. It allowed us to ingest about 10 gigabytes of data per day, but we ingested maybe 1 megabyte of data per day. So please check those settings. But on the other hand, try things out and see what happens. I haven't seen really zero to hero courses or anything. They might be there on what's it called? There are a few of the famous learning sites. Maybe there's something there. Second question on health checking databases and connections. That's always a hard one. When I'm having issues connecting to a database, what I'm using is the NSG flow logs, where it will tell you, did traffic come through this NSG? And if so, did it hit any of the rules? The flow logs are written in JSON, and they're quite easy to read once you get used to them. So make sure you enable the flow logs on the NSG, and you have access to the storage account where those flow logs are written, and just go from there and see if something is blocking access or maybe allowing way too much access if you're working. Does that answer the question? Okay, staying silent, so I hope it does. If not, please let me know.
Yes, no, that's good. They said yes. Okay.
Okay, cool. So time for a demo. I'm going to.
Oh, and then the other one was about the how like how to validate, like let's say for example that a past service like Azure SQL is locked down. For example, if you had a requirement to only connect to it from internally.
Yeah. Well, the first thing I would do was try to connect from it from any resource I can find that isn't supposed to be able to connect to it. That's my first step. Just see if I can break the system. And from there on, I know from SQL Server that it has the ability to log all the connections. So you can see what the originating IP address from the connection is. I'm not sure if Postgres has that option, but in the end, you want to prevent all the connections. So it's for me, it's usually checking the firewall, making sure external access is disabled or public access is disabled. And if you need to build exceptions inside the firewall for certain IP addresses or IP ranges, make sure they're documented. So you can, if there are any questions, you can just tell people, well, these are the ranges, these are the ones that are allowed in, and this is the reason behind it. That's how I would start. If that wouldn't be sufficient, then I would turn the question around and tell that customer, all right, you can hire another company and let them prove that I've done my work. Because in the end, if I'm proving that I've done my own work correctly, I'm checking my own work, and that just doesn't feel right. So if there's a really high need, get some company in to do the work for you. All right, let's dig into some code. I've shared my Visual Studio Code screen. And what you can see here is my PowerShell script. And this is right now a little bit magical. So let me walk you through it. I'm always starting with a file called main.tf, which is my starting point of every deployment. I'm telling it what kind of providers to use. So I want the Azure RM, which makes sure I'm using the Azure RM environment and not AWS. Or I think they support Google as well. And I'm telling it what version to use. Sorry. I'm not bumping version every time Terraform is releasing a new version. I'm just generally following them and upgrading versions if I really need them. Else, I'm just sticking to the versions that are working. Same for the Azure AD, because this part lets me use all the Azure AD stuff, like creating security groups, but also logging in. I haven't seen this being renamed to Entra yet, but that will probably happen quite quickly. This one is an essential one, the required version. This is the required version of the Terraform runtime. Terraform gets upgraded all the time. In this example, I'm using 1.5, which was the recent one from this summer, I think. They've upgraded already a few steps, but for now I'm using this one. Now, I want to make sure I'm deploying in the right environment. So I'm going to enforce my tenant and my subscription. But what's happening behind it? Because I've got tenant ID and that says var.tenant ID. Well, earlier I told you something about variables. So I can create variable files. And this variable file can hold all kinds of variables. Well, so I can tell it, where is it? This is my tenant ID. I've got a variable called tenant ID. I need to tell it what kind of type it is, what the default is, and what it's about. So in this case, the description is the ID of my tenant used For instance, for my key vault deployment, because when I'm deploying key vaults, I need my tenant ID. That's one of the variables I need to give to the deployment, and also the subscription ID. Every variable I can declare here, I can reuse in all the other files you can see here. So, for instance, my resource group naming, I'm naming it here once. Resource group identity, connectivity, security, whatever, all the resource groups, naming them once, reusing them wherever I need them. This also helps when I need to change naming. There's only one place I need to change it. I'll change the name right here from resource RG_identity to RG identity whatever. And it changes all through the code. The little word of warning though, if you change the name of your resource group, it's going to destroy your resource group and rebuild it. And with that, it's going to destroy all the resources in your resource group and redeploy them, which is not all that bad when you're in the testing environment. In production, it will give some funny things if you've got a lot of data in it because the data is gone. All right, so we've got a variables file, which we're referencing to. I need my local IP address to make sure I can connect to my environment. And I can create things like this. Random password. So this will generate my password for my virtual machine. As I'm deploying my stuff, I have no idea what the password is. It's being randomly created once. It will be somewhere in the state file, but it will be encrypted in there. And it will be available during deployment for my VM. So you've got my VM password. And I've got my SQL Server VM admin password. Yeah, cool. But now how can I ever retrieve it? Well, let's go to my key vault. Did I open this one? Ah, here it is. So here I'm going to create my secrets, my Azure RM key vault secret. In this case, my virtual machine password. I've created my Azure key vault in another file because I like to keep things separated. I'm going to name this thing my VM admin password. And the value is the result of my random password. So the result of this one. So it will save a 20-character password with special characters in my key vault. And the same goes for my SQL administrator password. It's in my key vault. And in my key vault, I can make sure only people with the correct privileges can get values from my key vault and use them. The same goes for creating my resource groups. I can create them here. I can create my network security group, and I can create my network security group rules. As you can see, I've named them. Network security group rule, allow Azure Data Lake storage inbound. Apparently, I need inbound connections to my data lake storage. It's connected to my resource group, which is defined here. My network security group rule must be in some kind of network security group. That's this one. And I've got my description. NSG rules allow inbound connections to the Azure Data Lake. Now I know what it's for. And everything from my virtual network can connect to my data lake. I'm not saying this rule is the best idea you can have, but it's working. So all my stuff is done here. And now I've got something else because I need some role assignments. In this case, I need to get my current user, being the deployment user I'm using to connect to my Azure environment, which is deploying. And I'm going to use this user to make sure I've got this right, key vault administrator, which means I can administer my key vault. Not only can I grant and revoke access to the key vault, I can also look inside my key vault. All the stuff I can inside the key vault I can see, which is quite handy because in the end I might be the one responsible to connect to the VM or the database. So I need a password. So right here, and as I said, you can download the code. I've got all the stuff. But now I need to deploy it. And what I'm using is, for my work, I'm using a more advanced one, but this it boils down to this one. I'm using a PowerShell script because, as most people, I find it hard to type, and usually I'm able to type the word deploy. Terraform usually already comes out like Terraform or something else. You can set a few parameters. So, do I need to log in? What is my tenant? What is my subscription? And do I want to plan or apply? Now, if you're using Terraform, you can use both flags. You can plan your deployment, but you're just going to tell Terraform, all right, check out what's on the environment and give me back what's there or not, and stop there. So I can see what's the impact of my new code. I can also tell it apply. What this does, it does a plan. It shows me the result and then asks me, do you want to continue to apply all your changes or do you want to stop here? So if you need to log in, I'm going to connect to my AZ account. I'm going to set my Azure contact and I'm going to log in that environment and then my code will start running. If I've set the plan variable, it's going to do in Terraform.plan. If I told it to apply, it's going to apply. And if I messed up and use both apply and plan, I'm going to write, please make up your mind because you need to do one or the other. So what does this look like when I start this stuff? Let me remove this one and start a deployment process. What you can see here, I've selected my deploy the PS1. I'm going to fill in my tenant and my subscription. I'm not going to plan it because that's got the false one. I do want to apply it. And then I'm going to hit enter. And at that point, Terraform is going to think, oh, what do I need to do? I'm going to get my local IP address for firewall routing and going to think about some other stuff. And it usually takes a few seconds before my screen fills up with a lot of information. In a few seconds, a lot of stuff came. I scrolled over my screen. So right here, I'm going to create an Azure virtual machine. Create it. Let's scroll up a bit. I'm going to create my virtual network. And I'm going to create an identity, security group association, a subnet, another subnet, another subnet. In other words, a lot of networking is done. My role assignment you can see here. You can see some text right here. So I've got my cost center, my deployment, all the stuff predefined in my variables file. You can see it right here. So I've seen it all. I've seen all green pluses, which means I'm going to deploy some stuff. So now I've got to think about what do I want to do. If I'm going to type in yes, it will start. Anything else will kill the process. So right now, Terraform again start thinking, what do I need to do? And a few seconds later, you'll see on the screen, things will start happening. It'll start say, I'm going to be creating stuff. So what it's going to do, it's call all the Azure APIs and tell the APIs, do this, do this, do this. And every, I think it's 10 seconds, it will check what's the progress. Did you create stuff? Did you create stuff? Is it running? Are we done? Are we done? And some things are created within a few seconds and others take some extra time. Now this video stops right now for the simple reason that every deployment, in my case, usually ends in some kind of failure. And it's not that I don't want to show you the failure. Thing is, some APIs do take some more time to respond to all the changes. I have built in some sleeps to make sure the code waits about 5 minutes for things like the AD to come back, for a keyful to come back, stuff like that. Now we've got it deployed. This is something I saw. I've got my resource group. Cool. They are deployed. I've got my tags. Like defined in my code, I've got my tags on all the resources. Let's look at my connectivity. I've got my network interface cards, I've got my network security groups, my private endpoints. Everything I want with that has to do with connectivity is in this specific one. I've got a network interface card, which is attached to a virtual machine, and it's attached to a network security group. I've got my network security group for my default virtual network that has an association with a number of subnets, which is cool, which means I've got rules to control all my traffic. I'm working a lot with data, so for me, my data resource group is an important one. I've got my private endpoint for my database, which might have been, should have been deployed in my connectivity group because that's where all my connectivity stuff is. So I might need to change my code. Moving resources between resource groups usually works. Moving resources between subscriptions is a whole different story. So make sure you deploy to the correct subscription, because moving between subscriptions can be quite difficult. But I've got stuff here. I've got my databases here. For some reason, there's a disk there as well. I think the data VM is in this one as well. Everything related to data is in my data resource group. So people working with data get permissions to view this resource group or maybe even interact with it. My network engineers, they haven't got anything to do here, so they won't get access. Network engineers cannot access my resource group data and therefore cannot access my data. When I'm looking at my networking for my SQL Server, I can see public network access from selected networks. So I can allow specific networks to bypass my firewall. Is this best practice? Well, maybe I should just disable it and only use private endpoints. Or maybe I need to find a balance for my connectivity. This is where things get hard. What do you allow, and what traffic are you not allowing? My identity has got my managed identity I can reuse for connectivity between resources. And in my security, I've got my key vault. When I'm looking inside my key vault, I can see my 2 secrets. And these secrets will hold my my password. So in the beginning of this session, I started out with architecting my security. What do I want to deploy? How do I need to think about all the stuff? I want to make it as secure as possible, get all my secrets in my key vault. So I thought about it. I learned my code. I wrote my code. I deployed it. And now I've got my results. I've got the basics of secure environment. So now if you want to play with this code for yourself, this is the link to my GitHub repository where you can download all the stuff and fool around with it and do with it what you want. It's free, open, whatever you want. Are there any questions?
I think we have a comment from Art that says
Yeah.
looks like Terraform. This bit, the code that you showed, is showing the deployment of the
Who
resources to
can
Terraform,
learn about this stuff?
similar to Ansible as well.
Yeah, I think he's got a point. From what I've heard, because I'm not really into all the Ansible Java stuff, but it's quite close related. Terraform is written in, somebody told me a few months ago. I think it is Go or Ruby, one of those. So yeah, it's one of those languages. For me, it feels a little bit like writing JSON. So yeah, it's all a bit Java related, I think.
Yeah, there's another question now here. Art saying, is it recommended to keep the .tf files in a separate Azure DevOps GitHub repo?
Which
Or
files?
the Terraform files, .tf
Yeah.
files. Yeah, to make a repo specifically just for the Terraform deployment, or do you put it together with an advantage of how you organize your repo to put it separate from like an actual application code as well?
I'm keeping it completely separate, including different privilege levels to make sure only the people developing the code can access it. And yeah, different repo for sure.
Another question from Keter says, "How can I learn all this stuff?" Yeah, I know, man. It's we all want to learn all this stuff, and there is a lot,
Yep.
for sure, in terms of material out there on the internet. As Raisa mentioned, the main providers, they all have their own learning material as well. I personally am a little bit biased because I work with Pluralsight, so I've created Pluralsight content, and I know actually when somebody mentioned that, I went over to check on the website, and there is a lot of material there as well, including a learning path if you want to do the Terraform Associate certification, which I think is
Hmm.
like the start of the
Yep.
Terraform certification hierarchy. So there's material there as well, directly following the path of or the learning guide of the Terraform certification too. But I mean, that's a great way to start. Sometimes people say, well, certifications, like when you get hired or not, like people don't really look, or they really don't, doesn't matter if you get certified or not. And that's, part of it is true. But what I found in general with certifications that's good is that it gives you a goal to shoot for and a structure for you to get
Yep.
going, right? Because a lot of people really struggle just with the get started part of it, right? Once
Yep.
you get familiar with something, then you yourself can kind of like discover your own learning plan. But at the beginning is the hardest thing. So that's where I find a certification is good. And if you really are serious about it, the best thing to do is to put your money where your mouth is. So let's say you see today is November 21st. So you go and you book a certification exam in 3 months from today, and you pay for it. That way, you're doing it and you paid your money. So you gotta study. Now the pressure is on, right? So I recommend people do that. They just book it, and then you'll figure it out. Then you'll start learning, and you'll know because the date is coming and you paid for it. So anyway, my 2 cents.
Yeah, no, I agree. When I started out with Terraform, we just started reverse engineering stuff. So getting some examples from the internet, running it, and reverse engineering what was happening there. And that's kind of a way I'm learning by finding out what people are doing and seeing if I can reverse engineer it. And then start building my own stuff and engineer my own code and see, well, does it work or does it break? So that's a bit of the way I'm working and learning. But yeah, following a certification path is always awesome to do.
Yeah, absolutely. All right. Well, I think that's all the comments and questions we have for today. On behalf of everybody, I want to thank you again, Reitze, for joining us today and sharing your knowledge.
Yeah,
And
you're
we
welcome.
will be posting the recording on the YouTube as well. Thanks, everybody. Have a good rest of your day.
Thank you.